Okay, this should be review. Okay, here's the kicker. Okay, understand when you have numbers inside and outside, when you're multiplying or dividing outside the function, it changes in a way the domain and range, in a way, depending on the function. Okay, we've talked about radical x real quick. Remember, radical x looks like this. Boop. Cubic root, though, looks like this. Boop, boop. And that changes domain and range. But if you're changing c, if you're adding to the function, that is going to change your types of answers that you're going to get. Okay, that is important because you're moving the important point. Okay, so let's talk about this. Example 1. How does adding a constant value to the output change the graph of the function? Okay, it changes the range. Okay, especially, actually in every function, to be honest, really except for cubic. For the quadratic one, this ranges from 0 is when y is greater than or equal to 0, but this one is when y is greater than or equal to 2. So all the answers move up 2. The same with this one. All the answers move down 3. Okay, so now you have a smallest range. Okay, this one here, move it up 1. Now your range starts from 1 to infinity. So the number on the outside changes the answer. It does not change the domain. It only changes the answers. Okay, when the number's outside. So let's look at this. Okay, how does the value of k affect the graph of the function for this one right here? Answers move up 7. So the answers move up 7. Okay, because of that right here, these answers move down 9. That's important. Okay, when it's outside, it moves the graph up and down, and that does change the range depending on the type of function that you're working with. If it's inside, that changes your domain, the types of x's you're allowed to plug in. Okay, so in this case, for this one right here, if it's absolute value, domain's not going to change, but it does move the graph. Okay, so notice for this graph right here, it moves the graph left 2. Okay, it moves the graph left 2. So let's look at the next one. Okay, right 1. This one up, on left 3. Okay, let's look at the next one here. This one, right 8. And this one, left 7. Okay, very, very important. If it's inside, left and right. If it's positive, move to the right. Negative, move to the left. Okay, outside, positive, move up. Negative, move down. Okay, last one, last page. Subtracting a constant value at this point. Well, let's talk about how it all moves. Okay, let's talk about this one right here. I'm not really going to graph it. The graphs are not going to make any difference. Okay, but let's talk about how to rewrite this one real quick. Okay, to rewrite it using that, it's going to be x minus 2 squared and then plus 3. Okay, so that graph is going to move to the right 2, up 3, boop, just like that. Okay, this one right here, it's 2 to the x minus 2 and then plus 3. And that graph is going to move. The important point, I'm going to move it up 3 and then to the right 2. Boop, just like that. Okay, then lastly for this one, this is going to be radical x minus 2 plus 3. Let's move that important point. Okay, boop, just like that. And the important point was 2, 3. And all the important points here are going to be 2, 3, except for this last one. There's a difference between this one because notice how it started at 1, 0. Okay, this one's now going to be 2, 4. Because I started at 1, I moved it up 3. It's 4, not 3. Because the important point was at 0, 1. It's not a hard lesson. Not a hard lesson. Okay, definitely need to watch the video and definitely need to just focus. Okay, understand the translations. Okay, and understand this language. Very important. That covers 10-4.